Hi everyone, today I'm going to explain about this question where the data given in the question is pasted at the left hand side and we are required to answer 5 sub-questions based on the data given. Firstly, I converted the data that was given in the question into a table form where there's the class of the insureds, number of insureds, and also the claim count probabilities. In the original data, there is a condition on the class of the insureds. So the next step is to convert the data into unconditional claim count probabilities where the condition of the class is included into the probability. First of all, we divide the number of insureds for each class by the total number of insured that was calculated here, which is 37,550. We do the same for each class from class 1 until class 20. Next, we multiply the probability of each class with each claim count probabilities that was given in the original data. Then we will obtain this table with the unconditional claim count probabilities that we can now use to solve the 5 sub-questions that were given just now. So the first sub-question is, one insured is picked at random, find the expected number of claims. So by calculating the expected number of claims means that we need to multiply the probability with the claim count respectively. So I have calculated the expected values for each class here, where the formula is to multiply the claim count with the probability of each claim count. 0 multiplied by 0.0266, 1 multiplied by 0.0266, 2 multiplied by 0.0266, 3 multiplied by 0, 4 multiplied by 0, and we add up all the probabilities. We do the same for each row until the last row. And finally, we sum up all the column O where it contains the expected number of claims. So this is the answer for the first sub-question where we are required to find the expected number of claims. Moving on to the next sub-question, one insured is picked at random, find the standard deviation of the number of claims. To find the standard deviation of the number of claims, we need to first find the value of EX squared followed by variance of X before calculating standard deviation. To calculate EX squared, we use the formula similar to expected number of claims, but the claim count needs to be squared by 2. So 0 square multiplied by 0.0266, 1 square multiplied by 0.0266, 2 square multiplied by 0.0266, 3 square multiplied by 0 plus 4 square multiplied by 0. We add up all the values to obtain the value of EX squared for each row. Finally, we sum up the values in column P to obtain the value of EX squared. Next, we apply the formula for variance, where variance is equals to EX squared minus EX to the power of 2. So here, C27 minus the square of C25, we will get the variance of X. Then standard deviation is the square root of variance. By then, we will obtain the standard deviation of the claim. Moving on to the third sub-question, we have, given the number of claim is more than 2, calculate the expected number of claim. In this question, there is a condition where the number of claim must be greater than 2. So the notation is written this way: Ex given x greater than 2. And the formula for this is Ex greater than 2 divided by the probability of claims count greater than 2. Probability of claim counts greater than 2 represents claim count 3 and claim count 4. Over here, we sum up the probabilities of 3 claims and also the probability of 4 claims. The addition of these two values is the denominator of the formula, while the numerator is the expected value, so we need to multiply. So we need to multiply the the probability of 3 counts by 3 plus the probability of 4 claim counts multiplied by 4. And we add them together divided by the addition of the probabilities of 3 and 4 claim counts just now. We will obtain the conditional expectation, which is the 3.712. For the fourth sub-question, given the number of claim is more than 2, calculate standard deviation of the number of claim. Similar to part 2 just now, we will need to calculate the expected x squared given x greater than 2. For this question, the numerator needs to be modified while the denominator is similar to the question in part 3. For the numerator, because it is x squared, we need to multiply the claim count by itself. That means we need to square the claim count. So 3 square multiplied by the total probability plus 4 square multiplied by the total probability, and then divided by the total probability of 3 and 4 claim counts, which is equivalent to 13.983. Next, we can move on to calculate the variance of this situation, where the variance is to subtract the square of expected conditional by expected of x squared given x greater than 2. So 13.98 minus 3.712 square, we would get 0.20514. Then we can calculate the standard deviation of x by multiplying variance to the power of 1 over 2, or square root the variance. So we can obtain the standard deviation of x by calculating the variance power of 1 over 2, which means we square root the value of x, where we will obtain 0.4529. Finally, we move on to the last question. Given the number of claims is more than 0, calculate probability of the number of claims that is more than 2. So this one, the notation is written over here, where the probability of x greater than 2 given x greater than 0 means we need to calculate in the numerator the probability of the claim count larger than 2 divided by the denominator, where the probability of claim count is greater than 0. So the denominator, the probability of claim count greater than 0, is the addition of the total probability of claim counts 1, 2, 3, and 4, which are calculated here, where each column we have added up the total probabilities for each claim count. While in the numerator, we require probability of x greater than 2, which represents the claim counts of 3 and 4. So we add up the probability of claim count probabilities 3 and 4 divided by the claim count probabilities of 1, 2, 3, and 4. This will result in 0.464690362. So by then we have solved the whole question and all the sub-questions in the question. That's all for today. Thank you.